All right, this video is on reintroducing proportional relationships. The goal of this video is to understand these terms, proportional relationship and constant proportionality, and to use a table to reason about two quantities that are in a proportional relationship. What is a proportional relationship? It is when two quantities are always in equivalent ratios. It is the balanced relationship that exists between two or more things. Here's a table that shows how many rolls of paper towels a store receives when they order different numbers of cases. This is a proportional situation or a proportional relationship, and I can identify that by seeing the connections that exist between the numbers. If you're able to double one column and then that results in a doubling of the other column, then it's true. It's proportional. So if you take the 5 and double it, you get 10. If you take the 60 and double it, you get 120. This is proportional. We could have done it here as well. I could have taken the 1, multiplied it by 10, and that would have given me 10, and then taken the 12 and multiply that by 10, and that would give me 120. So as long as you're able to use or replicate one set of numbers to another by multiplication or even division, then it is proportional. You can also see proportionality by seeing the connection that exists between the numbers from one column to the other. So to go from here to here, 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 it's the exact same operation. It's times 12. If you multiply this column by 12, you get everything in this column. That shows that this is proportional. So here is a recipe. The recipe says that 2 cups of dry rice will serve 6 people. How many people will 10 cups of rice serve? How many cups of rice are needed to serve 45 people? Well, we can identify this as a proportional relationship, and we can see it here by looking at these sets of numbers. We see to go from 2 to 6, you multiply by 3. And to go from 3 to 9, you multiply by 3. So we can use that to figure out what this would be, which would be 30. And then we can use that understanding to go from here to here by doing the opposite of dividing by 3, and that would give us 15. We are only able to do this because of the relationship of proportionality that exists between the cups of rice and the number of people. Another recipe says that 6 spring rolls will serve 3 people. Well, if we wanted to complete this, if it is proportional, which it looks like it is, then we see the connection here, which is divide by 2. Then just apply it here. This would give us 15. This would give us 20. And then we have to do the opposite here, times 2, and this would be 56. And again, we can only do that because of the connection between proportionality. So what is that number we're finding? What that is, that connection exists from one to the other, from the left side to the right side, that is called the constant of proportionality. It's a constant ratio or unit rate in any proportional relationship. It can always be found by finding how much of the second quantity per one of the first quantity. So we have a bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. Let's find the constant of proportionality to figure out how to go from one to the other. So if I go from here to here, I would take, 10 divided by 8, which works out to 1.25. I can apply that to all the rest here, times 1.25 times 1.25. That would give us 25. 16.25. And then to go the opposite direction, I would just divide by 1.25. And that would give me 16. So when looking at the bread dough problem, the constant proportionality is 1.25. We can multiply any amount of honey by 1.25 to get that amount of flour. It exists in every single one of these number sets. All right, now we have 4 quarters are equivalent to 10 dimes. That seems proportional. Well, what is the connection between this and this? It's times 2.5. How did I get that? I take the 10, I divide it by the 4, and that leaves me with 2.5. Well, that connection should lead me to have this be 2.5, this to be 15, and this to be 35, because they all are connected by that 2.5. And we can see that 2.5 right here. When the left column is 1, we can identify that constant proportionality by what's in the right column. So in the quarter and dimes problem, the constant proportionality is 2.5. And the constant proportionality is the same as the unit rate. That's why we can see it right here. When this column is 1, this column over here on the right identifies what the constant proportionality is. A recipe says that 2 cups of dry rice will serve 6 people. What is the constant proportionality for this table? Well, the constant proportionality is 3. I can see that because I can see the connection that exists between each of the numbers. Going from the left column to the right column, I would multiply by 3. I can also see it here where the unit rate, 1 cup of rice, is used for 3 people. Here as well identifies the constant proportionality. So I can see it going across, or I can go right to where the left side is 1, and whatever the right is, that is our constant proportionality. A recipe says that 6 spring rolls will serve 3 people. What is the constant proportionality of the table? Well, the constant proportionality is going to be 1/2. I see that because of the connection that exists between the left column to the right. To go from 6 to 3, I could divide by 2, but I can also multiply by half. And I choose that because when I go to the unit rate, where the left is 1, I see that the right column is half, and that is our constant proportionality. And it can be applied to every single one of these, including n, which is just saying any number. If you want to find the answer for the right column, you take the any number and divide it by 2 or multiply it by half, and you get the answer. Identifying proportional relationships from situations. The situation of a proportional relationship has 2 things you're looking for. The connection between the 2 things is made by only multiplication or division. And then 2, there is no extra involved in the situation that might involve any operation beyond multiplication or division. So that's the key. We're looking for situations where the results will only be found through multiplication or division. If there's any other operations that might be involved, it is not going to be proportional. So here's an example. At HPMS, there are 26 students per teacher in advisory. Is the total number of students proportional to the number of teachers? Well, to solve this, we could just go through and see what happens. Well, if I have 2 teachers, that would be 52 kids. If I have 3 teachers, that would be 78 kids. And if I had 4 teachers, that would be 104. So, because the connection is always going to be times 26, from here to here to here to here, this is proportional. Another example, the city pool costs $8 per day to visit during the summer. There is also a $25 yearly registration. Is the total cost proportional to the total number of days? We just do it again. We could just do 2 days, 3 days, and 4 days. But this time, I multiply the number of days by 8 but then I have to add this extra 25. So for 2 days, it would be $41. For 3 days, it would be $49. And for 4 days, it would be $57. And the connection from here to here to here to here is not the same. To go from 1 to 33, you'd have to multiply by 33. But to go to 2 to 41, you would not multiply by 33. So therefore, this is not proportional. So let's try this one. Aunt Joe put 3 towels on the clothesline and Sue put 6. All the towels are identical in terms of size, thickness, etc. It took 12 hours for Aunt Joe's towels to dry. It took 24 hours for Sue's towels to dry. Is this proportional or not proportional? And the answer is it's proportional. And it's proportional because the connection to go from 3 to 12 and 6 to 24 is exactly the same. It is times 4. Here's another one. Ashley and Megan are running around a track. They run equally fast, but Ashley started later. When Ashley has run 5 miles, Megan has run 12. When Ashley has run 30 miles, Megan has run 74 laps. Is it proportional or non-proportional? This answer is non-proportional. The connection from 5 to 30 is times 6, and the connection from 12 to 74 is not times 6. So they're not connected by the same number, and though they run at the same pace, Ashley started later, so that means there is some extra involved, either subtract or addition, which would account for a disconnect between the girls running. Entrance to a park costs $6 per vehicle. Additionally, each visitor pays $2. Is this proportional? Well, looking at the table, to go from here to here is times 5. To go from here to here would be times 2.6. So the answer is not proportional. And the reason why it's not proportional was, if we go back to the original problem, is that there was that extra added on. You had to pay per person, but then there was the extra money for getting just the car in. All right, let's look at identifying proportional relationships from tables. Proportional versus non-proportional. If two quantities are proportional, then they have a constant ratio. If the ratio is not constant, the two quantities are said to be non-proportional. We will make tables and look at the relationship between the variables to determine proportionality. Proportional or non-proportional. In order to tell from a table if there is a proportional relationship or not, you can check to see if the ratio of y over x is the same. This ratio of y over x is also known as the unit rate. So we have to find this unit rate, and if it exists across every single set of numbers, then we know that the table is proportional. So here's an example. The following chart shows how much money Alex earns for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? So if we look and we take the money he's earned and divide it by the number of hours, we always get 14 over 1. It doesn't matter if it's 28 and 2, 42 and 3, 56 and 4. That combination shows that the result will always be $14, which is the unit rate, $14 per hour. Since the simplified ratios were equal, this means this was a proportional relationship. Here's another example. Ticket Express charges $7 per movie per movie ticket plus $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Well, when we take that same process of taking this and dividing it by that, we end up with a unit rate of 10 for the first one. But then it changes to 8.5, 8, and 7.75. you're not getting the same ratio. And since all of the simplified ratios are not equal, there is not a proportional relationship between the cost and the number of tickets ordered. The reason why is when we go back to the situation, we have this extra. You're adding on this $3, but you're not adding the $3 to every ticket. You're adding it to the order. So if I buy 2 tickets, I'm only adding $3. If I'm buying 3 tickets, I'm only adding $3. That's why it's not proportional. So tell if the following table is a proportional relationship. Is it proportional? Yes. Why? Because we found that the unit rate of taking the y, which is the right column, and dividing it by the left column, you end up with a unit rate of 2. Tell if the following table represents a proportional relationship. The answer is no. It is not proportional because when we look at the combination of dividing y by x, taking the right column and dividing it by the left column, you end up with numbers that are not equivalent. So it is not a proportional relationship. Identifying proportional relationships from graphs. The graph of a proportional relationship has 2 things going on. One is that the line, it has to make a straight line and it passes through the origin, or 0, 0. And the second element is the unit rate or constant proportionality is found by taking any point and dividing the y coordinate by the x coordinate. If it meets these 2 things, then it is a proportional relationship. So let's graph this proportional relationship. We have hours, earnings, and then we're going to graph that over here. We put time on the x-axis because it's in the left column. And we put the earnings on the y-axis because it's in the right column, ignoring this column for the moment. So we end up with these points. Well, it goes in a straight line and it passes through the origin. And if we were to take any of these points and divide the x over the y, you get 14 for each of these. And the constant proportionality, or also known as k, would be 14. That is the unit rate for this problem. Now let's graph this non-proportional relationship. Tickets ordered will be on the x-axis because it's in the left column. And costs will be on the y-axis because it's on the right column, ignoring that third column for the moment. And we look at it, it does form a straight line, but it does not pass to the origin, so this is not proportional. Now, is there a constant proportionality? Yes, there is, but we're not going to talk about it right now because we're just focused on proportional relationships. But yes, there is a constant proportionality, but it's not as clear on this graph when it's non-proportional. All right, let's identify which of the following graphs represent a proportional relationship. Well, the answer is only this one. This one meets the criteria needed to be a proportional relationship for a graph. It's a straight line and it passes through the origin. This passes through the origin but isn't a straight line. This is a straight line but doesn't pass through the origin. This is a straight line and also doesn't pass through the origin. So the only one that works is that one. Identify which of the following graphs represents a proportional relationship. Well, the answer, it was actually 2. This one and this one. All 4 are straight lines, but these 2 are the only ones that pass through the origin, making them proportional. Which of the following graphs represents a proportional relationship? Well, it's only this one here. Straight line, yes, but doesn't go through the origin. Not a straight line. And it is a line with multiple steps, so not proportional. Tell if the following graph represents a proportional relationship. The answer is yes. And why? Because it's a straight line that passes through the origin. Tell if the following graph represents a proportional relationship. The answer is no. Why? Though it's a straight line, it doesn't pass through the origin, so that makes it non-proportional. Does the following graph represent a proportional relationship? The answer is no. Why? Yes, it's a straight line, but it doesn't pass through that origin point. Does the following graph represent a proportional relationship? And find the constant proportionality. The answer is yes, it is proportional. It is a straight line, and that straight line does pass to the origin, so that makes it proportional. And we can identify the constant proportionality by looking at the 2 points that are given to us. We were given 20 and 60 and 10, 30. And remember, points are always x and then y. So we know that the constant proportionality k is y over x. So 60 divided by 20 gives us 3. Or if we took this point and we did y over x, that would be 30 over 10, and that would also give us 3. So that's why this is also a proportional relationship.